Alright, Steiny, this video is for you, bud. This is for your A on this next test. So, you got the senses. And Bosma said there's 6 senses. Smell, taste, you got somatic senses, hearing, sight, and your dynamic equilibrium stuff. So, the first one we're going to be going over is smell. And so, to smell particles, basically enzymes from your food, air, enter the nose. They get trapped by the hairs of your nose. Just look up your nose, you're gonna see a bunch of hairs. And around the hairs, there's this watery fluid. And the enzymes get dissolved in this watery fluid. And then they come up into the upper portion of the nose. It's called the olfactory bulb. And the enzymes, once they get broken down and they come through into the olfactory bulb, they get broken down and get into the receptors. And originally it was thought that once they make these receptors, these enzymes will fit into this one slot and that will be the smell. But that wouldn't make sense because we need to have like a trillion different keys or locks to be open. And it just wouldn't make sense. So what scientists now think is that when an enzyme comes up into a lock and opens it, that it sends a molecular tingling or impulse to the brain, and that's how we sense smell. All right, so up next we got taste. So basically, taste kind of works the same thing as smell. And it also directly correlates because 70% of what we smell is what we taste. So how taste works is taste pores. So basically taste buds, those are little bumpy things in your tongue, and taste hairs, which protrude from your taste buds, which are portion sensitive. You don't need to know that at all. And so when we digest food, in our tongue, where we break down the food, we chew it, and in between the little cracks of our taste buds, these enzymes have to get down beneath those into the epithelial cells. And then kind of the same thing as smell, it goes through a lock and key type thing and it sends a tingling impulse to the brain. You can go here and say the molecular combination, that's a little bit advanced, but as long as you say the enzymes come to the receptors and send an electrical impulse to the brain, you should be good. All right, up next we got sound. This one's a little interesting, a little more information here that you'll probably need to know. So sound, obviously the ear. So in order to hear, our ears are specifically designed to be able to gather sound. So we call the outside of the ear the auricle. And so sound waves bounce off our ears into our middle ear, basically like to our eardrum. You got our ear canal and the eardrum. And the eardrum vibrates, causing these 3 tiny little bones in our ear. There's names to them, but those are all complicated. So just go with the Advil, the hammer, and the nail. And when those vibrate, they cause fluids in the, I'm gonna call the coachella, to vibrate, to move, which causes hair cells in the coachella to send an electrical impulse. And these hairs will only move if it's that certain sound, so basically only certain hairs move if there's a certain sound made. So because only certain hairs move, our brain is able to tell the type of sound from the electrical impulses that the hairs moving makes, and that's how our brain interprets sound. All right, up next we got sight. This one definitely a little more hefty in the vocabulary. So light has to enter our eye. That's called the cornea. Light passes through the pupil, center of the eye, and then from there it goes to the iris. The iris is basically kind of like, think of it as like the stop guard. It's going to control what you see or how much light you see. So if the sun's out and you look directly into your sun, the iris is not going to let you do that. So it's going to close, make you blink real quick. So once it hits the iris, it hits the lens. Basically, there's probably a name to it. I don't know it. And then the lens is focused, basically dilation. It's a process called accommodation, just another vocab word to throw in there to make him think you know what you're talking about. The lens then focuses the light rays to the retina just back of your eye. And then you have the optic nerve in the back of your eye, basically just goes straight to the brain and it sends the image to the brain. That's how we use our sense of sight. All right, up next, we got kind of the two little bit more interesting ones. We got static and dynamic equilibrium. So static equilibrium, this has to deal with like where our head is moving and moving in the head. And both these two, static and dynamic equilibrium, all happen in the inner ear. So inside the macula, again, part of the inner ear, hair cells come into contact with otoliths. Now, otoliths, think of these as like little Orbeez. They're like little balls, kind of like, and they react to kind of like kids in a foam pit. So basically, as we move the quote-unquote macula, basically our head around, these otoliths adjust to this movement. So basically, gravity causes the otoliths to move, which sends a message, again, from hair cells to our brain, indicating if we're rotating, bobbing our head up and down, anything like that. All right, now dynamic equilibrium. So dynamic equilibrium, again, starts the inner ear. And it's these three semicircular canals that are all on 90-degree angles that have fluid in them. And when we move our head and this fluid moves past a certain point, it again causes hair cells to generate an impulse, which causes dynamic equilibrium is to maintain balance. So when we tilt our head or like walk around in certain ways and an object in motion stays in motion and this fluid moves past this point, it's able to relay to our brain, hey, we need to take a stride with our right foot, now left, in order to maintain balance. All right, up next, we got the somatic senses. So somatic senses are pressure and temperature. So to feel pressure, our body has three different types of receptors. There's it's called the meridians, free, and another one. Basically, our body has receptors for soft, middle, and deep tissue pressure. So that's all you need to know, because otherwise it'd be way too vocabulary heavy and way too difficult to understand. And then for temperature, all you need to know is that our body's thermoreceptors, yes, vocabulary, thermoreceptors, send out pain impulses when our body reaches temperatures over 45 degrees Celsius, and when they release pain cells when our body's below 10 degrees Celsius. So anywhere from 45 to 10 degrees Celsius, our body is not sending anything out to the brain at all about temperature. But when it is above 45 degrees Celsius and below 10 degrees Celsius, our body is sending pain impulses saying, hey, get me out. I don't want to be here anymore. All right, Steiny, so that was the senses. I hope you get an A on this test, bud. Boom, boom, boom. See you, Steiny.